In this video, we're going to look at the unit circle. We want to be able to know the radian, degrees, and coordinates of the points on the 16-point circle. We're going to be able to evaluate any trig ratio from any of those points, and we want to be able to evaluate any trig ratio of a coterminal point to any point that's on that circle. Remember, when we talk about the unit circle, we're talking about a circle that has its center at the origin and has a radius of 1, which means that these quadrant points are the point 1, 0. Up at the top, we have 0, 1. On the left, negative 1, 0. And at the bottom, 0, negative 1. So you should know those quadrant points pretty easily. Next, we're going to look at the middle point in each quadrant, which is, of course, created by that 45-degree angle. So we look at this triangle. This is a 45, 45, 90 triangle. Remember, the radius is always 1, so I know the hypotenuse is 1. So then each of these are a value of x because they have to be the same value because the angles are equal. So if we just use the Pythagorean theorem, we're going to have x squared plus x squared equals 1 squared. Doing some algebra. So just doing some basic algebra, we get x equals plus or minus the square root of 1/2. This is an area where you will normally be asked to rationalize the denominator. So if we rationalize this denominator, so we end up with x equals plus or minus radical 2 over 2. So what that tells us is that at this point, since I'm in the first quadrant, both of them are positive, so I'm going to choose positive answers here. So since I'm in the first quadrant, both of them are going to be positive, so I'm going to choose two positives, so radical 2 over 2 and then radical 2 over 2. The other 3 points that are these yellow dots, the middle of each quadrant, are going to be the same. We're just going to change the sign. So when we come over here, we're going to get negative radical 2 over 2 and then radical 2 over 2. Down here in quadrant 3, they're both going to be negative, so negative radical 2 over 2, negative radical 2 over 2. And then finally in quadrant 4, only the y-coordinate is going to be negative, so radical 2 over 2 and then negative radical 2 over 2. So now we've got the quadrant points, and then we've got the middle point in each quadrant, so we just need the other 2 points in each quadrant. Those points are very similar. So if we look at this first one, this is a 30-degree angle. This is my right angle, which makes this a 60-degree angle. Remember, again, my hypotenuse is 1. I know that this side over here is 1/2, because if we draw in the triangle that is symmetric to the bottom, then this would also be 30 degrees, and this would be 60 degrees. So that would give me an equilateral triangle, so this whole side here would be 1, and then this is obviously bisecting it, so then this is just the 1/2. So then we just need to find this y value here. So then we just really want to find this x value here. So again, I'm going to use the Pythagorean theorem, so we're going to go x squared. So we're going to do x squared plus 1/2 squared equals 1 squared. So just doing some algebra. And then simplifying, we get x is plus or minus radical 3 over 2. So then coming back up to this point here, tells us that this x-coordinate is the radical 3 over 2, and the y-coordinate is the vertical, which is the 1/2. So now I can get these other 4 yellow points in here from those. So coming over to quadrant 2, the x-coordinate will become negative. Moving down into quadrant 3. In quadrant 3, they're both negative. And then moving over into quadrant 4, only the y-coordinate is negative here, so we have radical 3 over 2 and then negative 1/2. Moving over to the other triangle here, we're going to get the other 4 points that we're missing there. So now this is a 60-degree angle, this is the right angle, and then the 30-degree angle is up here. So we have the same triangle that we had over here, we're just changing its orientation in the circle. So now this side is the 1/2, so that's my x-coordinate, and then my vertical, which is going to be my y-coordinate, is the radical 3 over 2. So then at this point right here, so this point we get is 1/2 radical 3 over 2, and then we can get the other 3 points again just by changing the signs. So then you've got your whole circle, all 16 points. Our goal is that we want to be able to find any trig ratio of a point that is on the circle or coterminal to a point that is on the circle. So here we're looking at finding all 6 trig ratios of the 315-degree angle measure. So I want to find that angle measure, which is here. So it's this point here that we're looking at. And then what we have to remember is that the cosine value is my x-coordinate. The sine value is my y coordinate. My tangent value is y over x. And then we can also do our reciprocal functions using our definitions. So remember, secant is the reciprocal of cosine. So the secant of theta would just be 1 over x. The cosecant is 1 over y. And then cotangent, remember, is the reciprocal of tangent. So I can just flip the y over x and make that x over y. So in this specific instance, when we want to do cosine of 315, we're going to go to that point at 315. Cosine's the x-coordinate, so I'm just going to take that x-coordinate, and it's going to be radical 2 over 2. My sine value is my y-coordinate, so negative radical 2 over 2. Now my tangent value is my y value over my x value, so we're going to have to do the y value, which is the negative radical 2 over 2. Divided by the x value, which is radical 2 over 2. And hopefully you recognize that that's going to be negative 1 because those are the same two numbers, but one is positive and one is negative. Then if we go on to our reciprocal functions, so the secant of 315 is the reciprocal of cosine. So if I flip my cosine value, that's going to be 2 over radical 2. Again, this is a place where we're going to rationalize, so we're going to go ahead and multiply by radical 2 over radical 2. 2 radical 2 over 2, the 2's would cancel out, so we will just have square root 2 there. So cosecant 315 is going to be the reciprocal of sine, so negative 2 over radical 2. Again, we're going to rationalize this, and we'll end up with negative radical 2. The cotangent of 315 is the reciprocal of tangent. Tangent is negative 1, so its reciprocal is just negative 1. So just looking at a few more examples here. We're doing the cosine of 5 pi over 4, so you want to look around your circle and you want to find 5 pi over 4. So 5 pi over 4 is this point here. And then you want to look at what function they asked us for. They asked us for cosine. We're going to remember that that's the x-coordinate. So at that point there, my x-coordinate is negative square root 2 over 2. Next, we're going to do the secant of pi over 6. So pi over 6 is this point right here. So then again, I'm going to look at the function that they asked me about, secant. Secant is 1 over cosine. So this is 1 over my x-coordinate. So I'm going to come here, I'm going to look at my x-coordinate, it's radical 3 over 2, so I'm going to flip that and make it 2 over radical 3. And then again, this is where we're going to rationalize. And we're going to get 2 radical 3 over 3. Finally, here we're doing tangent of 7 pi over 4. 7 pi over 4 is here. Tangent, remember, is the y value over the x value. So we're going to do negative radical 2 over 2 over radical 2 over 2. And again, these are the same values. One is positive, one is negative, so that's going to give me negative 1. All right, so next we're looking at this 480. So we start looking around our circle, but my circle only goes to 360. So remember, then if it's not on the circle, it has to be coterminal to something on the circle. So I'm going to subtract 360 degrees here, and that's going to give me 120. So 480 is coterminal to 120, so I'm going to use this point here. Then again, I'm going to look at what is the function they asked me for. The function they asked me for is sine, so that's my y-coordinate. So at this point here, my y-coordinate is radical 3. So my y-coordinate there is radical 3 over 2. So next we're doing the cotangent of negative 270. So if you have a negative angle, the easiest thing for me to do is find the positive of that angle and then go straight up or down from that. So 270 is right here, but we want negative 270, so I'm going to go straight up from that. So technically where I need to be for negative 270 is here at this point, which is 90 degrees. We're doing cotangent. Remember, cotangent is the reciprocal of tangent, so it is x over y. So here my x-coordinate is 0 over my y-coordinate, which is 1. 0 divided by 1 is 0. So remember, if 0 is in the numerator, that's fine. The answer is 0. If 0 is in the denominator, then that would be undefined. Next, we have 210. 210 is on my circle, so that's just right here. We're doing cosecant, which is the reciprocal of sine. So this is 1 over y. So here my y-coordinate is negative 1/2, so I'm just going to flip that, so that's just going to be negative 2. 13 pi over 6. Start looking around your circle. You remember 13 pi over 6 is not on my circle, so again, what we have to do, remember, is find the coterminal rotation. So we add or subtract a whole circle. So 13 pi over 6 minus a whole circle, which is 2 pi, which would be 12 pi over 6, gives us just pi over 6. So I'm at this point right here. We want the cosine value, which is the x-coordinate, so my answer is just radical 3 over 2. So then we're looking for 5 pi over 6. 5 pi over 6 is right here. We want the sine of that value, so sine is just the y-coordinate, so my y-coordinate there is just 1/2. And then here we're doing negative pi over 3, so remember, find pi over 3, so here's pi over 3. Since it's negative, I want to go straight up or down, so I'm going to go down here to this point. So this is the point that I want to use for negative pi over 3. Also on the circle, it has some of the negative rotations on it, so you can see that there. Then we're doing tangent, so remember tangent is y over x, so I'm going to take, this is going to be negative radical 3 over 2 divided by 1/2. Remember, instead of dividing by a fraction, I can multiply by the reciprocal, so I get negative radical 3, and we get negative radical 3 over 2 times 2 over 1, the 2's cancel out, and then we get negative radical 3. All right, finally the last thing is that we're going to kind of go backwards just a little bit here. So this says find the acute angle. So remember, an acute angle is between 0 and 90 degrees, or 0 and pi over 2. So that means we're only working in this quadrant right here. So we're only dealing with these points. We want to find the angle in both degrees and radians to solve this equation. So where is the sine value radical 3 over 2? Remember, sine is my y-coordinate, and I'm only working in quadrant 1, so I'm just going to look through quadrant 1 until I find that y-coordinate that's radical 3 over 2. So then my answer is the angle rotation. So theta is in degrees, 60 degrees, or in radians, pi over 3. So this second one, where's the cosine value? Remember, cosine is the x-coordinate. So where's my x-coordinate? Radical 2 over 2. So that happens right here. So at this point here, my rotations, my angle rotations are either 45 degrees or pi over 4. The next one is asking me where is my tangent? Radical 3. So remember, tangent is y over x. So I'm just going to jot those tangent values down. So this would be 1 over 0, which would be undefined. This would be radical 3 over 2 divided by 1/2, which is going to give me radical 3. Here my x and y values are the same, so that's just 1. Here I'm going to have 1/2 divided by radical 3 over 2, which is actually going to give me radical 3 over 3. And then here we're going to have 0 over 1, which is going to give us 0. So where's my tangent value? Radical 3. That happens here. And again, at that point, the rotation values are 60 degrees or pi over 3. And then this last one is cosecant. Where is my cosecant value? Equal to 2. So what we want to do here is take the reciprocal of both sides. So the reciprocal of cosecant is sine. So I'm going to write this, sine of theta. And then the reciprocal of 2 is 1/2. So taking the reciprocal of both sides, we get a simpler question. Where is the sine value? 1/2. So where's my y-coordinate? 1/2. And that happens here. And then at this point here, theta is either 30 degrees or pi over 6.